Perfect. Let's make sure I can share the correct screen here. Okay.
Looks good. Yeah.
Perfect.
We can see your notes though. Just no, sorry. Those are just no. Oh, good. Sorry.
Yeah, those are just captions. I just put those on there to try to assist, especially since I have a strong American accent.
Sorry to interrupt. We can't see your screen, I think, here online, but
maybe we want to.
it seems that we cannot see it in the room.
I think
Just
we can fix
give
this.
us 1 second.
Yeah. Sure.
Okay.
Sure.
Yeah. Okay. That's solved. Thanks to Mike.
Perfect.
Lovely.
Perfect. Okay. Then I will keep going here. So David and I are both at the University of Virginia, and we're looking at forecasting global displacement, and we're looking at sort of two very related models. So a Heckman model, selection model, and then also a hurdle model for thinking about people who have been displaced for various reasons. We're going to talk about those various reasons. Let's see if I can, there we go. So I think this is not a terribly big surprise, especially for folks really interested in this panel. But we have a humanitarian problem. We have a humanitarian crisis, right? Basically, since 2012 to 2022, we've more than doubled the number of people who are forced to flee their home country. And there's a lot of different things you could see across the board, across these different types of issues. So internally displaced persons, so people who stay within their country but are forced to move, refugees, asylum seekers, all those groups that overarchingly they've increased in quantity. And so there's this underlying trend. So when we think about trying to model or forecast this information, we have to think that there is an underlying trend over time. So there's a major time component. There's a huge persistence component to trying to model this situation here. And on top of that, we have huge country effects, right? So literally 8%, if not more, of those displaced people come from Syria, right? And if you actually look at the Syrian displaced people, whether refugee or internally displaced, it's at one point reached up to 75% of the population was displaced, right? And so when we think about this problem, we're looking at very specific countries that have really strong effects going on, okay? And it also then means that there are some countries, you know, where you have strong effects as a percent of the population, but aren't nearly the size quantity, right? So small island countries that may have large displacement of, for them, 10,000 wouldn't even appear on the chart, but that's a huge issue for them. So our response variable, the variable we're really interested in is globally displaced persons. And in that case, we use the UNHCR data, and we just look at internally displaced persons and we look at refugees. There are other categories. We're going to set those aside for now, mostly for definitional purposes. And we're going to look at country year observations. So we're going to look at, you know, essentially Syria in 2002. We're going to look at Venezuela in 2001. We're going to look at the US in 2017. Okay. And we're going to truncate observations below 1,000. That it cleans up some of the data because places like the US technically have some, and even the UK have some measure of internally displaced persons, whether it's a measurement error, whether it's a technical legal definition that goes into it, right? So basically, if it's less than 1,000 persons, we're going to treat that as sort of a zero. So basically, you have to have over 1,000 people displaced for it to count, for us to count it as a displacement event, right? And this, we're going to start in 1993, which is the first year we have internally displaced persons information from the UNHCR. And so that we essentially have up through about 2000, okay? And so we don't have a ton of years, but we have at least a large enough panel to be able to ask some questions. One of the other issues then that we immediately run into is, you know, there's a wide range of explanations. If you go look at the academic literature, if you go look at what's being done sort of by practitioners at different organizations like the UN and Save the Children, the organization we're working with, right? They have a bunch of different covariates that are really that are potential, right? We know GDP has a huge effect, right? What are the resources people have, and things related to that? What's the level of democracy? Can people work things out between themselves? Is there a civil war going on, right? The sort of conflict things that cause people to be displaced, right? We're also interested in climate. How does climate affect things, right? As food resources become more scarce, or as it's essentially land becomes more scarce as sea levels rise, there's going to be more conflict between individuals. Who's going, resource scarcity can drive conflict, right? And vice versa, right? That climate the conflict can, in the conflict areas, you're going to have more less resilience to climate issues, right? So if there is already a war and then there's a drought, those things are going to compound on each other. So, as I've already mentioned, we have two modeling issues. One is we have a bunch of zeros, roughly, truncated zeros, right? So that's that in that first table there, that's that huge spike at 0, right? And so, but then we have a very large spike, and I sort of made the histogram a little truncated so you can at least see that it's not just all zeros, but there's, we also have a lot of really huge events. So that's 1 million or more people displaced at the very end of the table there, right? So it's rare and unusual, right? Almost all the observations are zeros or near 0, but there are observations that are really high. And then the second chart, you can see that sort of global displacement is persistence, right? So it has these long sort of peaks and troughs in there over time above sort of the long run mean. And so we need to deal with that level of persistence. Okay, so modeling issues, right? The persistence, obviously, we have an issue with modeling it from our standard OLS. So we need to think about what are the two issues: the time and the fact that there are these state components, right? That Syria, that Venezuela, that Colombia, that the Democratic Republic of Congo has caused have a lot of things going on that we can't sort of explain with just individual covariates, right? That with individual explanatory variables. So there's a lot going on just within those countries over time, right? And some of it is we want to do rare events analysis. The just standard approach is the Poisson and negative binomial, right? So we think about these counts of people, and those are sort of the bits, but they assume that zeros and non-zeros come from the same distribution, right? That there's some sort of same underlying thing that's causing both the zeros and the non-zeros. The other thing to note, of course, in rare events analysis is it's driven by these huge events, right? So Syria is going to drive a lot of the analysis. Afghanistan is going to drive a lot of the analysis. Also, of course, with anything looking at a global scale, we have a huge issue of missingness, right? So a lot of these variables that we were really interested in, you saw these huge lists, right, are missing for a lot of countries, if not entirely for that country, at least for certain years it's missing, right? And so we could use some sort of multiple imputation, which is some, Amelia is what that is, there are various forms of imputation we could do. As far as we're aware, this gold standard is still list-wise deletion. So the idea is if that observation is missing that particular variable, that particular feature, then you delete it from the analysis. And that's still the gold standard there. So with that approach, we then use, so our actual model is a generalized linear mixed model, right? So we're expecting these globally displaced persons to covary with changes within that country. So as things change inside Syria, we expect to see some level of change, and we expect to see differences between countries, right? So Syria has different capacities than, say, Turkey does, even though they're close to each other, and so we would expect to see different sort of effects going on in those there, right? And so in that case, we need this mixed model to be able to model that, right? To have some level of clustering at the country level to deal with those things. And honestly, adjusting the standard errors is not enough if we expect to see these things to happen, right? And so that we want to employ these mixed models with these different intercepts, right? One of the reasons we're sticking with a standard statistical regression instead of doing something like a random forest or logistic regression in machine learning terms is we want to create sort of the best baseline we can with the sort of long run statistical techniques, things we've sort of done. We've seen several papers that sort of put together a fixed effects model or whatever model and then show that that their machine learning technique does better than that. But if you, when you go look at the mixed model that they put together, the statistical model, it's not a particularly good model. So you would not expect to do well. It sets that bar really low. We want to set the bar pretty high so that when we start developing better and better machine learning and AI driven models, we have a good bar to set. And we also want to know why. And some of this may just be the academic in David and myself, but we want to have some inference of what's causing the displacement. And it also then, when we can talk about why, we can talk with the people in the field, the qualitative folks who are seeing different things, and they can say, hey, we're noticing this happening, and it seems to be leading to more people being displaced in this region, right? And then we can go look at that in the data and say, hey, we can see that as well. And we also see this, or hey, we didn't actually see that. May be true in your case, in whatever country you're in, but it doesn't seem to be a common factor throughout things, right? So we want to be able to talk about these things at individual levels, and then we also want to be able to supplement, because data are not everywhere that we can record or that we have recorded. So then they can give us sort of, if you're working with a practitioner organization like Save the Children, they can provide their own warning system, essentially. So if we don't have data on that particular country, but that's, the people in country are looking at it, they're able to provide some advanced warning. So there are two different models here. The first is the Heckman model. And so here, the idea is you model selection, you model 0 or 1. Do we observe more than 1,000 people displaced in a given country year? And that to do that, we do logistic regression with a binomial distribution, right? And then you sort of step back from that, you take some of the results from that, and then you put together the conditional model. If the above is true, if we've got a 1, how many people were displaced? And in this case, we're using a negative binomial distribution. We're expecting, obviously, there'll be clusters around closer. We're going to see more country years closer to 1,000 than we would expect to see closer to 1,000,000. Should not be terribly surprising, but that's so that's why we use the negative binomial distribution. The other approach is to use a zero-inflated truncated negative binomial model, which is really the hurdle model approach. And so that one, then it uses the zero-inflated component to be that binomial distribution, explain XX zeros instead of 1s, but it's just a sign change there. And then it's a truncated negative binomial to just do the rest of it, to look at how the magnitude of the displacement event. And then it's truncated in that case because we're not trying to fit the zeros themselves. In our case, we sort of pick 3 different groups. We look at violence, right? We look at climate, and we look at economic variables. Here we pick these variables mostly because these are ones that we have very good coverage, country year coverage. And so there are a lot of variables we were really interested in, but as soon as we started implementing them, we started tossing out countries here and there. And we know that we're not missing information at random. And so some of the other models, the ways to imputation methods are not robust to dealing with some of these things. So in our case, we're making the decision to, hey, we need as much coverage as we can, and so in that case, we picked these particular variables in this comment. I'm not going to go through those here. There's a list there. We can always chat later, but just see that there are 3 different groupings: violence, climate, and economic, and there are a few variables under each of those. So in our case, we train on 1993 to 2017, and then we test over 3 years, 2018 to 2020. We also have some baseline variables, so we want to include population, right? If your country only has 200,000 people, we don't want to create some sort of expectation that you're going to have more than that. We also look at the highest democracy level of your neighbors to see some level of regime ability, sort of the ability of that regime to take people in, the ability for those people to see that there's a place that they potentially can improve their outcomes. And we also introduced time knots because we saw that time trend. So we're not modeling time explicitly, we're sort of treating it as a nuisance variable at the moment and trying to capture it with those time knots. And then we have a random intercept per country in order to deal with the sort of country effects that we can't deal with because of the missingness bit. And then we lag all the explanatory variables by 1 to try to create some level of causality argumentation. And then we compare different combinations of the models, right? So we're going to, on the next slide, we'll look at, violence, and then violence and economic variables versus climate variables. And doing all this, we use the GLMM-TMB-R package throughout. So let's look at some of the results. So the selection model, I think we do pretty well with, right? And so you can look at the table here and look at the different models, right? Again, violence, economic, climate, and different combinations. And then the full model is all three of those combined. And we can see that overall, looking at in-sample prediction is false positive, false negative, out of sample prediction, false positive, false negative. Again, false positive being we predicted that there would be an event and there was an event, and then false negative being we predicted there would be no event and then there actually was an event, right? So in the selection model, we do okay, right? We're well under 10% total, and most of the models are predicting under 5%. So and so in this case, we want, again, we're biasing ourselves towards including more states, and so we run with the economic variable because it does well across the board. Is ranked, second, if not first, second or third, and it has a lot of states in there. As opposed to if we go down to the full model, you see we drop down to 109 states, or in this case, states are countries. And so, or if you look in the in-sample, you drop from 162 to 148, right? So we want to keep as many countries in there. So the economic model does quite well across the board. And so we're going to stick with that relatively simple, right? So in this case, GDP and GDP growth is a good predictor of whether or not we have a displacement event. Excuse me. A conditional model now. So when we actually are looking at, when we have an event happen, how big it is, this is where we start having some issues, right? And so in our case, again, we're looking at over and under prediction. In this case is greater than 50% difference from the observed value. And so here we have a very large over prediction happening, both in sample and out of sample in this case. But if we look, we could see that when we include all three sets of variables, so violence, economic, and climate, that full model at the bottom, all three of them contribute to actually minimizing our over prediction. It's not the best under prediction model, but the dramatic decrease in over prediction is really what sort of throws it in that direction. Unfortunately, that's also obviously the model that's going to have the least number of countries. And so, but at the same time, we still have, 109 in sample and 80 out of sample to look at. And so we've stuck with the full model. So let's look at sort of, what we get. So when we look at particularly the best fitting model and look at the actual versus predicted, you can look at the table here at the chart here, excuse me, and sort of see who are the outliers, right, in this case, right? And most of them are somewhat predictable, right? Afghanistan, Iraq, you can actually see, that we're doing okay with some of the other countries, right? The one that really we're having a really hard time with is Colombia, and so we're both massively over predicting, massively under predicting in Colombia, and so that's one of the ones where we're looking at that case in particular and seeing what that's going on. So if you think about it, if we removed Colombia, right, we'd actually probably fit Afghanistan pretty well in this case. And if you look at the residuals plot, you can again see it. Colombia and Iraq are the really big offenders as far as not modeling those two particularly well. And so in this case, our best fitting model is not looking at those issues amazingly well. Modeling it all together here. So we tried to do then that zero inflated truncated negative binomial. If you look at the results, again, so the zero inflated is the selection model, the truncated is the conditional model, and it properly corrects standard deviations. So the estimates are the same, but the standard deviations, right? So our confidence intervals are going to be a little bit off, but unfortunately, it doesn't predict particularly well. It's kind of the same as sort of essentially just an intercepts model, right? Just looking at time and countries, but it performs significantly worse than the full model, and we're not 100% certain why that case of that is. So moving forward, and running out of time here, we seem to be able to model selection fairly well, but when it comes to the size of an event, we're only doing slightly better than the monkeys. And so we're always interested in some more feedback of particularly why is the zero inflated model that that the model that puts it all together performs so poorly to the Heckman model, and then just whether there are alternative standard statistical modeling approaches that we just haven't thought about in our approach here. And so that's just couple thoughts that we're really interested in. If anyone in the audience has some thoughts on those, that'd be great. And that's all I have for y'all. So thank you.
Great. Sorry, I didn't want to kill the applause. Sorry. Thanks for that. Thanks so much. So I don't see if there are questions in the room, so I would give priority to those if there are. Otherwise, I'll have some questions at my end. Or is there any questions from the room or so? No. Okay, right. Then I'll proceed with no. Okay, so then I'll proceed with a question from my side. Look, what is the lag for some of these variables to be available, right? I mean, like for example, like maybe the GDP for 2019 takes a couple of months, years, whatever, to be available, right? Or maybe this violence estimate is done in retrospect or something sort of. So just curious, like from a forecasting point of view, how early could you actually make, like operationally, like a forecast, let's say for next year, right? It would not be January 1st, I assume, right? Because it takes some time for the variable to be available, right?
For sure. Excuse me. Yeah, for sure. So obviously it really does depend on the country, right? So most OECD countries are going to spit something out quarterly, right? And so you're generally about 2 to 3 quarters behind. Obviously, though, to get the huge coverage that we're looking at right now, we're looking at about 18-month lag, essentially. So that's the sort of from when the end of 2020 had just come out essentially earlier on this year, or last summer, depending on the country, right? And so we've built it to constantly repull the data, but it doesn't really update a ton. And so we should try to create a larger cross sample at the end. We sort of do kind of this 18-month, 2-year cutoff. And we are modeling it annually at this point in time. We could try to go a little bit more discrete, but then again, not every country reports at that level, and our big goal is to try to get as many countries in this as possible.
Sure.
Yeah, and then I saw, David's already answered the question, but thinking about COVID-19, and so we do have war variables in our model. We don't have any sort of disease variables at this point in time, and so some of that is because they're not tracked as well, and then particularly COVID-19, right, is also something that starts in 2019, and so it would be if you model that discretely, we would have many less a lot less data. We'd only literally have maybe 1 to 2 years worth of data in that case.
Sure. Jerome, sorry, I think I cut you off. I think you had your hands raised before. If you're still, please go ahead if your questions are relevant.
Yeah, well, it's a simple question. Just wondering. Great work, first off, Luke. Wondering if if anything's available online, say the data or maybe even the code that you used to run some of this stuff. I'd be curious to kind of learn and see what you did more granularly.
Yeah, so at this point we haven't put it online. We're primarily working with Save the Children. I should have said that up front, and working with their group. So we're looking to put together a report from this in the near future, and then the code, and we'll create a GitHub repository for all of this, and then it will be available there. So my hope is by the end of the summer we'll have something for you, but feel free to email either David or myself and we can give you access to whatever's there. Unfortunately, we just haven't. We just finished the model like literally a week ago and then put this together. So we're still working towards that part of the pipeline, so to speak.
Cool.
Great.
Thanks.
Thanks, Jerome.
And maybe one last quick question from Andre, if it's possible. I think we have 1 minute, so if it's quick.
As quick as possible. So thanks a lot, Luke. Very interesting work. And I was just wondering whether you had anything to share, whether you experimented a little bit with different type of migration flows. I guess you can differentiate a little bit. I don't know, maybe asylum versus aggregate flows, or maybe even labor migration. So just to see whether you can add something to that.
Yeah, for sure. I'll try to answer that real quickly. So we did look at a little bit with asylum. So the thing with asylum, because some of what we're trying to see is, which of these groups of variables. We already know with asylum that at least for a lot of countries, has to be the violence component to it for a lot of asylum claims. So that's part of why we didn't necessarily do asylum in this case, just because we kind of already know that violence is there, and we can. So that's sort of biasing towards that result, so to speak. Some of the other bits, so like labor migration and whatnot, we haven't included at this point in time. Again, a lot of it has to do with coverage issues, and wanting to build something that we can do really cross-nationally and long time frames to get a lot of observations out there to see if there are some trends in there. The labor stuff may actually we may have enough years out there for that. We haven't looked at that, so that's a good comment to put out there, and I'm sure David has some thoughts on that as well, and whatnot. But thank you for that suggestion. It's a great question.
Great. So thanks. Let's